Hey class, we're going to do the last problem from rotation quiz 2, number 3. This was my favorite of the problems that I wrote. I'll read it first. It says, Sam is designing a theme park ride that spins you around in a horizontal circle with a radius of 20 meters. He collects data and finds that kids don't reliably puke when the centripetal acceleration is less than 4 meters per second squared. Sam does not want to clean kids' puke. To what values should Sam constrain his angular velocity? All right, first let's write down the information we know. We know that the radius is equal to 20 meters. It's pretty big. It's pretty large ride at this theme park. And he wants to make our constraint. So let's write this out. Our constraint is that the centripetal acceleration should be less than 4 meters per second squared. Okay. And then the question is, what should be the range of omega? Should it be greater than a certain value, less than a certain value, between two different values? That's what he should decide. First things first, we need some way to relate r, omega, and centripetal acceleration. We should have these equations memorized. They are on an equation sheet, but still, we should know them well. Using these two equations together, we could plug in this definition of linear velocity in for the velocity over here, and we get AC is equal to r times omega squared over r, which as you simplify, you'll see it becomes r squared omega over r squared omega squared over r. Then one of these r's cancel out, and you get r times omega squared. So that's the equation we'll use. Let me write down centripetal acceleration is equal to r times omega squared. Now let's think, what can we do from here? Something that is good to do for these kind of constraint problems is to think about them graphically. Think, what happens if I increase this variable? Will this variable also increase? Will it increase exponentially? Will it decrease? What kind of relationship do these two things have? So this, you should see, kind of lines up with y equals m times x squared. If you were to plot y versus x over here, you get a plot that looks something like this. You would plot, instead of x, you'd plot omega, and instead, has units of radians per second. And you'll plot centripetal acceleration over here, which has units of meters per second squared. We'll plot this upper bounds, this constraint, of 4 meters per second squared. And now, based on this x squared, we know any graph that looks like y equals mx squared will have an exponential relationship. So let me just draw what that exponential parabola-like thing looks like. And we know over here, we cannot exceed this centripetal acceleration of 4. So we have to find what value of omega does that happen. And do we want to constrain ourselves to values of omega that are greater than that or less than that? So first think, we start off, when you're on a ride, you start off with a low angular velocity. And as you increase your angular velocity, it becomes less safe, and kids start to puke when you get above it. So first let's just write down that over here we're at a frowny face, and over here we're at a smiley face. And so we're going in this direction. We're speeding up to get faster and faster. Once we get to this angular velocity, the kids will start to throw up. So we have to make sure our angular velocity is below that amount. To figure out what that amount is, what that angular velocity is at our constraints, let's plug in the value 4. And so we'll say 4 is equal to r, which is 20, times omega squared. As we simplify, you see that omega squared is equal to 0.2, and you could further simplify that, take the square root of both sides, and you'll get omega is equal to, I wrote down the answer here, 0.4472. I included extra digits over here because I want to talk about how to round. We want a value that is less than that, so instead of rounding up to 0.45, that would actually make kids puke if this 4 meters per second constraint is accurate. So instead we'll round down to 0.44, and we'll say omega has to be less than 0.44. and the units are radians per second, in order for these kids to not throw up. Okay, so that's the full answer. Make sure you can understand this graphically. Think about which side we're approaching this graph from, and interpret your answer at the end. All right, that should be it. Let me know if you have any questions. See you later.